Number 9. Graph shows which x is x cubed. Find the inverse function. So we write, oh goodness me. So we write y equals x cubed. Switch the x and y. Make y the subject. So we're undoing something being cubed, which means we are. Which means we are cube rooting. Which means our function, our inverse function, is the cube root of x. Sketch the graph on the diagram above. Well, we know that inverse functions are reflections in the line y equals x, and the line y equals x is a diagonal line going through 0.5, 0.5, 1, 1, 1.5, 1.5, 2. Okay, so there is our, oops, obviously you'd use a ruler for that if you wanted to. Well, that's to make it look better. And then we are reflecting in there. Oh, it's a bit dodgy, but hopefully yours will be better than that. Okay. Now, next one, number 10. And the graph is so we can see that this is a quadratic graph. We know it crosses the axis at 2 points, and we do know the coordinate of the vertex. Now, I would suggest that all we know is the y coordinate of the vertex, so we don't know the full coordinate of the vertex. So when we're trying to work out the equation of this, we'd be using the x-intercept general formula. But first thing they've asked us to do is to sketch it. So if it goes through at -3, 0, try and make your scale as accurate as possible. So -3 would be about there, and 1, 0. Again, I'd suggest 1 was about there. We know it goes, the vertex goes up to 4. Now, some of you were putting your y-intercept at 4. That's not what it says. It says the vertex is at 4. We know for parabolas they are symmetrical. So the vertex is going to happen halfway between these points 1 and -3. So there are 4 units in between the points 1 and -3. So the vertex is going to occur at this value of -1. So we need to plot the coordinate -1, 4. That's going to be our vertex here. Label anything as appropriate, and then we can draw in our graph. Okay, now it says find the values of a and b. So we need to find the equation of the graph. Well, as I said, we would use the x-intercept format. So we would have y equals a bracket x. In this case, we know it goes through -3, so it would be +3, and goes through +1, so it would be x minus 1. Hopefully we can see that that it's a negative parabola, so we know the value of a is going to be negative, but we just don't know how negative it is. Now, in the past, we've often been told the y-intercept, but in this case we haven't, but we have been told the vertex coordinate. So the vertex coordinate is -1, 4. As I said, the -1 comes from the fact that it's midway between the -1 and +3. +1 and -3 intercepts. So what we're going to do is stick these two values in. So it's 4 equals a bracket -1 plus 3, -1 minus 1. 4 equals a, so -1 plus 3 is 2. -1 times by 1 is -2. So we've got 4 equals -4a which means A is negative 1. Okay, so we can then put that back into this version here. So we've got y equals negative x plus 3, x minus 1. And we now need to expand it out. So using FOIL, I've left my negative alone for now. So using FOIL, I've got x squared minus x plus 3x minus 3. Again, leaving the negative. Join like terms, so that's plus 2x minus 3. And then negative x squared minus 2x plus 3. So going back up to here. Oh, apologies. We did know the y-intercept, so we could have also put the value of x as 0, y as 3 into there. So identifying A and B, so A in our case is negative 1. And B is negative 2.